Welcome to the second module when we're talking about test development. We're going to talk now a little bit about further considerations for writing questions. So these really are important questions as we're developing and designing a test. One of the other things we want to ask is the construct that we're measuring, is it unidimensional or multidimensional? So we've kind of made an assumption in most of our communication and most of what we've been lecturing on, or I've been lecturing on in this class, that we're actually after a construct that requires multiple questions to get at. It's multidimensional. So when we talk about content validity, do we ask enough questions to get at the construct of interest? When we talk about face validity, we're talking about how many items, do the items look like they're measuring what they're expecting to measure? And even when we're looking at reliability, all of our reliability measures are looking at whether those items are all measuring the same construct. However, behind all of that is a very simple question to begin with. Do we actually need multiple items to measure a construct? There are some constructs that actually are measured fairly easily by a single item. So a unidimensional construct is one that only requires a single question. A good example of this basically is job satisfaction. Job satisfaction generally is involving a fair amount of important subcomponents. So it is a complex construct. But research has actually found that a lot of the times, asking all those complex questions about individual aspects of job satisfaction will still get you one general measure of how much do you like or dislike your job. So in that case, especially if we're really just wanting to get a quick feel for people's attitudes towards the workplace, we can use a unidimensional single question to measure job satisfaction. So I have a very simple, and this is actually used in some cases, scale of job satisfaction. Now it's a little bit, the FACES scale has actually been used in job satisfaction. The descriptors is my attempt to be a little bit funny. So the lowest level there is I'm loading up my weapons, a little bit of dark humor. Please kill me, work sucks, can't wait for Friday, it pays the bills, I love my job. Now, the other thing we have to ask is, remember when we were talking about test development, the first thing that we're asking when we're doing the 5 phases of test development is why are we actually designing the test in the first place? How complex is the construct? What is the construct? And then also, what are we going to use the test for? So if we're creating a job satisfaction scale that's only purpose is just to do a quick gauge of how satisfied are our workers, then we may choose a unidimensional scale. However, if we're designing one that's supposed to be used to identify where the problems are, if people are dissatisfied, we don't get that from this unidimensional scale. All we know is whether people are satisfied or not. So a multidimensional scale is a scale of job satisfaction with many questions trying to get at the complexity of the construct, but also to give us information about where the problem is. So this is the job satisfaction inventory, at least a portion of it. And for each thing on this scale, you're basically talking about the work, the pay, your opportunities for promotion, supervision, and it goes on. There's also elements on basically bonuses and extra benefits. There's a section on your coworkers, and each one of these. Now again, if all you're interested in is finding out are people generally satisfied, this would be a pretty big waste of time for them to fill out all of these items. But if you're interested in not only how satisfied they are, but how satisfied they are with the various things that construct or make up job satisfaction, then a multidimensional scale would be better. So each of these have their advantages and disadvantages. Unidimensional scales are really quick and easy. We don't really have to worry about reliability. As long as the question is written well, it's a good written question, there really is no check for reliability. It's a single item. We can't really compare it to anything. Now, we can look for its validity. Does it relate to things we'd expect it to? So a unidimensional scale of job satisfaction, for instance, should be highly negatively correlated with people being late or people quitting the job. The more satisfied they are, we'd expect them to show up on time and stay with the job. The more dissatisfied, the more likely we'd find it for them to be missing work and to be possibly quitting. However, again, the disadvantages is that if we find a problem, we really don't have a good idea where that problem is. Multidimensional scales can be averaged to create a single measure of the construct, and often are, but they also provide us that information of what's going on. They give us more detail. But they also now require us to go through a larger process that every question needs to be made sure that it's a solid, good question, and that there's reliability in the scale. It also usually takes people longer to take the scale. So whenever we're creating questions, we should be following the rules of communication. So this isn't just for the individual questions, but also the series of questions we're asking. So generally speaking, we want to start from the general to specific. Whenever you start a conversation with someone, you usually don't immediately start with very specific questions. You start with pretty broad general questions. So tell me a little bit about yourself. What do you do for work? You wouldn't start with, so when you come in at work, for the very first 5 minutes, how are you feeling about your job? That's a very specific question. And if that was the very first question you asked someone, you'd probably get a pretty interesting response, because it kind of breaks our norms of how we communicate. If you meet someone for the first time, find out their name and say, so what do you do for a living? That's a pretty broad general question. As much as is possible, when asking opinions, when asking people questions, you should think about starting with the more general questions. So, for instance, if you've got a series of items that are looking at anxiety, if you've got 2 or 3 items that are generally, I feel anxious. In certain situations, I get nervous. And then later you have questions like, the 5 minutes before I'm taking a test, I feel. In that case, unless there's a reason to do it otherwise, you want to start with general and move more towards specific. You also want to save sensitive questions for later. So if you are asking sensitive questions, so if your survey is eventually going to start asking questions about sexual behavior, illegal behaviors, illegal drug behaviors, again, you want to start general before you get to the specific questions, and you also want to start with fairly innocuous questions. So I would never open up on a drug questionnaire right off the bat of whether someone is doing methamphetamines or shooting up heroin. You'd probably start with, how often do you drink? What are your attitudes towards drinking? You might ask then a few questions about marijuana and build up to those more sensitive questions. Generally speaking, demographic questions should be put at the end. Because the other thing is again, following the rules of communication. You don't want to be boring. So you want those first general questions to kind of get people interested in your survey. So when you open with demographic questions, those are honestly boring questions. So they're not asking someone their gender, their age is not necessarily engaging their interest at that point. Another thing is, the longer a survey is, the less time people are spending paying attention to the questions. But demographic questions, usually people rarely get wrong no matter where they are in a survey. So again, we put demographic questions towards the end or the very end of most surveys, unless we need a couple of those for screening. So what screening means, and this especially works well in computerized testing, so if you're doing it online, is that if there's a certain demographic group that should not be taking your survey, have that question right at the front, so that they can basically save their time and save you from collecting bad data. So if your survey is only looking at women's issues in the workplace through the eyes of women, you'd probably want to have that demographic question right off the bat. Do you self-identify as a male or a female? If they mark male, the online survey could immediately then say, please discontinue now. You're not eligible to take this survey. For every question, you want to make sure you provide sufficient instructions. So you want to make sure that people are understanding what the question is asking. Is there a context to that question? So for instance, if you're doing an anxiety scale and what you're wanting is anxiety and dating, but your questions don't necessarily mention dating specifically, you would want to start out with specific instructions. Answer the following questions regarding how you feel prior to going out on a date. Let people know how they're supposed to be interpreting those questions. And also, sufficient instructions include how are they supposed to respond. Circle only one correct response. Please fill in a single bubble. So again, if your scale is meant, especially if it's a pen and paper scale, to only have one response per item, make sure that you communicate that. You can actually set up on online surveys to where people are only allowed to choose one option, so that's easier. You also want to make sure that you allow for variability. So basically, again, this is making the assumption that you're asking questions that have a continuous response, or multiple responses. So again, remember that idea from the previous set of slides that we want it to be exhaustive and mutually exclusive. So the measurement scale being meaningful is that the response options you provide should capture all reasonable responses to your question. But you also want to make sure that it allows for variability. One of the things that people often have a problem with is basically what's called floor and ceiling effects, and I'm going to give an example of that on the next slide. But what this really refers to is that you have created a strongly worded question that most people are all going to respond the same way to, even though you've given them more options. So floor and ceiling effects. I would like to have $1 million. Disagree to agree. Well, in this case, very, very few people are going to disagree with $1 million. So if we assume that we're making a scale about material greed, this isn't going to give us a lot of ability to look at variability. In fact, almost everyone is going to respond in exactly the same way. This is a ceiling effect. Everyone agrees with the item. You don't get any variability. You can't discriminate against people. You can't use this for correlations. You can't predict anything with this scale. Likewise, material wealth is the only thing that is important to me. Well, again, very few people would actually agree with that. Most people would agree that it's not the only thing. Now, we might get a little more variability, but still we're going to see what's called floor effects. Everyone's disagreeing with the item. Again, hard to run correlations, hard to do prediction. So both of these could probably be fairly well written. So instead of $1 million, depending on the income bracket of the people you're giving this test to, you might want to choose an amount that's a little bit more reasonable, and you may also want to word the question to where they would have to do something they might not want to do to get it. So for example, I would be willing to lie for $50. That would probably get a lot different responses, and you might want to make it specifically. I would tell a harmless lie for $50. In that case, if given out to this class, we might find some people disagree completely, strongly disagree. No, I'm not going to lie for $50. A few people, they disagree. I don't know, it depends on the situation. And some people, it's a harmless lie, sure, give me $50. We're going to see variability. So now we're actually getting at individual differences in how they'd handle the situation, which is what we're after. Again, material wealth is the only thing that's important to me. Again, we might want to say material wealth is the primary thing that is important to me. We'd probably get some more variability. Or material wealth is one of the top things that I think about as far as what makes me happy. That again might get us some more variability. So some additional tips for writing questions. One thing to think about with each question is to kind of run through this little thought exercise of think of the sample that you're planning to give these questions to. So who's going to take this test? Do participants have the information? So a lot of times when people come in and talk to me about grad school, one of the first things I ask them is, what's your current GPA? A fair amount of students kind of look at me and go, and they have a guess, but they actually don't know. If we ask people, what are your ACT scores? Some people might remember them, some people don't. I honestly couldn't even guess what my ACT score was at this point. It's not something that's been important to me for many, many years. So when we ask people questions, the first thing we want to know is, do they actually have the information? You also want to be careful about eliciting a certain type of response. So in class, I gave a very quick example. If you were there that lecture day, I basically ran through an exercise where I had the class spell various words. I had them spell mop, I had them spell top, I had them spell, some other op word. I don't remember off the top of my head. I had 3 of them. And then I asked them very quickly, what do you do at a green light? And almost everyone said out loud, stop. That's a very good example of basically framing or anchoring effects. The idea that the order of questions starts to actually affect the additional questions. So one of the things we want to think about is the order that we put questions in. And again, this is something you just have to kind of do a thought exercise and ask. Are these questions that I'm asking starting to get people to think in a certain direction? And then is that going to influence later questions I have? So sometimes test developers will try to get around this by just randomly ordering the questions. This can especially be done, again, on an online format where every single person is getting the questions in a different order. This tends to kind of even out the order effects across all your participants. Or, again, kind of thinking about if this is a question that's really going to basically be having people think in a very specific way. So if you're asking a question, for instance, and this is another reason to have sensitive questions towards the end of a survey or questionnaire. But if you're asking a question that when someone responds to it, they're going to be kind of forced to recognize that they have done a behavior that they might not be proud of. If you then follow that with some self-esteem questions, their self-esteem is probably going to be lower at that exact instant. So you might want to put those self-esteem questions earlier, and then the questions that might make them feel bad about themselves later. You want to avoid leading and loaded questions. So loaded questions and leading questions are very similar. Loaded basically means that you put loaded words. So a loaded word, for example, is upset. Anything that, any word that elicits an emotional response is a loaded word. So if you talk about a lot of adjectives, so are you concerned with the staggering debt of the United States of America? Well, staggering pretty much it's a very emotionally loaded word. Leading questions are ones that basically tell you why you shouldn't answer the question in a certain way. So should we increase income tax, which would place an additional burden on the poor? Well, that's a leading question. That's basically saying, do you want to hurt the poor? So instead of simply, should we increase income tax, that's a non-leading question. Now we can make it a loaded and leading question. Should we drastically increase income tax, which would place an additional and unsustainable burden on the poor? We've actually loaded the question with emotional-laden adjectives, and it's also leading people in how to respond. So how upset would you be if your friend smoked pot? Again, this is a leading question and a bit loaded. So upset is an emotional word, but also notice that this assumes that you would be upset. So it's not giving the option to say, I wouldn't be upset at all. It assumes that you should be upset. Anchoring effects refers to that, especially with numbers, if people are being asked about numbers, so what's your income, what's your age, we have a tendency that if we're then asked for questions that we don't have as strong of an answer for, so for instance, a very good example of this is if you ask someone their age, followed by how much TV they watch, there's actually a correlation between age and TV watching that shouldn't be there. Because age, we all know. So if I say 18, that means that the number that's in my head as I answer the next question is a relatively smaller number, 18. If I answered 75 to my age, it's a relatively large number. The next question you ask, how much TV do you watch? Very few people actually can answer this easily. The only people that really can are those that watch no TV or very little TV. So most people are going to make a ballpark estimate. They're probably not going to sit there and actually think about day by day and add it all up. The people that are younger are going to tend to answer a little bit smaller number, and the people that are older are going to answer a larger number because it's an ambiguous question that we don't have an immediate numerical answer for. You can also do this with guessing things. So basically, if I ask you a multiple choice question and the answer responses are all in the thousands, and then I ask you how many feet a building is, most people are going to put their guess at the height of a famous building somewhere between the highest and lowest number on the previous question. This is, again, an anchoring effect. So it's, again, an example of response order. The question before is now influencing the question after. And where we see it the strongest is with numerical questions. Finally, double-barreled questions. Anytime you write a question, you want to ask, am I asking more than one thing? So if there is an and, an or a but in your question, it often becomes very hard for someone to respond on a forced choice response option to that question in a way that's meaningful. So I am against Governor Rayner, and I think the state of Illinois is going in the wrong direction. The problem with that is that a fair amount of people might agree with both items, but there may be some people that strongly support the governor but do think the state's in the wrong direction, or hate the governor but think the state's going in the right direction. So a double-barreled question is one that's asking two things, which basically makes it hard for the response option to be mutually exclusive and exhaustive. Again, question wording, whether it's positive or negative has a pretty strong effect. So this is actually from some political polling that was done at various times. So looking at 1940 and 1976, these are two national polls, and in both cases they changed basically a single word. Do you think the United States should forbid public speeches against democracy? So basically banning something. Or do you think the United States should allow public speeches against democracy? Now again, in this case, the only difference in this question is whether we're talking about it from stopping it or we're talking about it from allowing it. So looking at 1976, the question yes to the first question, yes, it should be forbidden. 21% of America in 1976 said that yes, we should forbid public speeches against democracy. However, in the same year, same people, 47.8% said no, we shouldn't allow it. So a lot more people were against allowing it than were against forbidding it. So we don't necessarily like to forbid something in this country. But when we ask, should we allow it? Well, we shouldn't allow it, but we wouldn't be willing to forbid it. So again, one word change, and we're getting very different responses from polling. And again, do you think the United States should forbid public speeches? Again, 78% said no, we shouldn't forbid speech in this country. However, only 50% said that we should allow public speeches against democracy. So anyway, this is just an example again how question wording is very influential on how people respond to questions. And polling companies know this, which is why it's very important again to know who's doing the polling when you look at poll results. So scoring and scaling, this basically is just how do we actually put numerical numbers to the responses that people put on surveys. If they are questions that are not clearly objective, so in other words, the forced choices, scoring usually is simply a process of assigning numbers to the responses people gave. However, there are situations where we may have some interpretation of, especially if it's a paper and pencil, maybe they circled an item, but they kind of circled two. What did they mean? And definitely with open-ended responses, so fill in the blank in essay, we need raters to actually determine what was the attitudes of the person based on the words they put down. Was their option correct or not? And we then want to ask, do we want one or multiple raters? Generally speaking, the more raters we have, the easier it is for us to look for rater agreement and therefore reliability. So when possible, we want multiple raters. We also have to decide, do we allow partial credit versus correct or incorrect? So on a lot of my multiple choice, not my multiple choice, but my fill-in-the-blank questions or essay questions, a lot of times I allow some partial credit. So there was a correct answer, you didn't get it, but the thing that you put down was pretty close to the concept we were talking about. I may give some partial points. And finally, when we're talking about scoring, are instructions and training required? So do we need additional instructions on the test for people to understand it? And maybe even do we need to train people on how to respond? A lot of tests, for example, like the GRE and a lot of online testing, will give you a few sample questions that aren't actually scored. That's a built-in training on how to actually answer the questions. Scoring and scaling can also be, do we decide to weight the items by item difficulty, the effort or time spent, reliability? In other words, are certain items worth more points or not, based on how difficult they are, how hard they are to do. So for example, on the test that you take in this class, I generally give more points sometimes for essay test questions, especially if they're a little bit longer than multiple choice. So I'm giving you more points because of the effort and time required. So we're going to end up this section on item analysis. This is looking at not reliability across all items and not whether we're actually measuring what we think we're measuring, but we're actually looking at this point of the individual items. So the nature of item analysis will depend on the goal of the test developer. Among the tools test developers might employ to analyze specific items are an index of its difficulty, often referred to as P, an index of its reliability, which is calculated with R, the coefficient of reliability, an index of the item's validity, coefficient of reliability, also R, and finally its ability to discriminate from top and bottom performers, or D. So how difficult is it, how reliable is it, how valid it is, and how well it discriminates or predicts future behaviors. So item difficulty, what is the reasonable range for difficulty? And this is a choice. You may be wanting to make a test where all the items are of equal difficulty. You may be wanting to make a test that has some very easy items, some moderate items, and some hard items. And again, these are choices that are going to be driven by why is the test being developed in the first place. Item discrimination is like convergent or predictive validity, but on an item scale. We're asking how well does each item, not the whole scale, but each item discriminate between top and bottom performers and a future behavior. Items must discriminate between levels of an external construct or overall score. So how does each item predict the outcome? How much does each item predict marital satisfaction, whether someone has ADHD, how much anxiety someone suffers from? But again, instead of looking at the entirety of the scale, we're actually asking, kind of like with Cronbach's alpha, which of these items are working really well, and are there items that we might as well drop? They might be reliable items, they might be even valid items, but they're not items that are actually helping us determine future behaviors. So computing item discrimination, we're going to talk about two equations here. And this is a quick way to actually determine how well an item is actually discriminating. So we already kind of talked about item difficulty in previous slides. So remember item difficulty, that first one we talked about a few slides ago, that P, that is simply what's the percentage of people that get that item right. The higher the percentage, the easier the question. The lower that percentage, the lower the that item. And when we look at reliability and validity, we've talked about both of those well. Again, the higher the reliability, the more we can trust the validity. And those are both calculated with R, basically 0 to 100%. So discrimination, our equation here, we have two different equations. The first equation is from Aiken 2000. It's a fairly simple equation, but the main thing to remember about this equation is this bolded part. This is best when the item has basically the number incorrect or number incorrect are near equal. So we're basically looking at items with about a 50% difficulty. So when we have that, we can actually use this equation. So U is the upper half and L is the lower half. So what we're doing here is we have an item, and that item has difficulty of about 50%. So we now are going to use to determine how well the item discriminates between good and bad totals score on the test. So we're looking at the item versus the total test. So for instance, if the number of correct of the upper portion of the test in the number correct in the lower portion. So what this means is that we take the entire everyone that took the test, and we divide them in half to where U and L are basically somewhat equal. So again, we take the top test performers and the bottom test performers. And then we take the individual item and ask, of the top performers, the upper performers, the U, how many of them got this question right? And then of the lower performers, how many people got this question right? So these are the two amounts. And so if we have, in this case, we basically got a total of approximately, so I'm sorry, I paused there for a minute. But what we're looking at then is we have the number of people that got it correct from the upper by the number of people that got it correct by the lower, divided by just simply the number of people that are in the upper category. Now again, U and L should be approximately equal, the number of the people in the upper category versus the lower category. So this means that we're basically subdividing a group in half, top performers versus bottom performers. And as long as we're doing that, we can use this equation. So on the top of the question, again, is the number of people that got it correct from the upper group. So in this case, notice that in U, the bottom of the equation is 50. So assuming that we have a near equal group of 50 people that were in the upper group and 50 in the lower, that tells us we had about 100 test takers. Now of those test takers, the 50 that were in the upper category, 30 of them got it right. Of the 50 people that were in the lower category, the bottom of the distribution, 15 got it right. So the equation then is the top is the number of people in the upper grouping, the people that are in the top performing half, got right, minus the number of people in the bottom performer that got this one item correct. So 30 minus 15. 30 minus 15 is 15. The bottom of the equation is simply the total number of people that were in that upper distribution, your top performers, and that's 50. So 15 divided by 50 equals a D of 0.30. This gives us how well this item discriminates. And this item is not a great discriminator. It discriminates somewhat. Think of this a little bit. It's very similar to correlation. So this item basically is somewhat related to top performers, but bottom performers are getting it right too, just not as often. Now, what happens though if you are not splitting it necessarily in half? So again, that previous equation was based on the idea that we actually have an equal number of people in the upper group versus the lower group. Top half of the distribution, bottom half of the distribution. But a lot of times in work settings and in clinical settings, we're not necessarily looking at top half and bottom half. It might be we're looking at top third to bottom two-thirds. It might be we're looking at the top 25% to the bottom 75%. And in that case, we need a different equation. Now, generally speaking, both of these equations have the same mark. We're looking for a D of 0.35 or higher. That's kind of just a rule of thumb. So our last equation on the last slide did not quite make that requirement. So we're going to use this equation when the U and the L, again, the upper part of the distribution versus the lower, are not equal. We didn't split the distribution in half. We're splitting it in 25% versus 75%. And usually that upper part is going to be the smaller percentage. So in this case, we're going to use the equation above, where we're dividing the number of correct in the upper group by the upper group, and then subtracting the number correct in the lower group by the number in the lower group. So let's run through this equation. So discriminate between high and low scores. This is again from Aiken, but this is the conversion when you don't have an equal split. So in this case, the number of people that were in the lower category, or the upper category, were 50, while the number of people in the lower category were 100. So it's not equal. So again, we look at the number of people that are in the upper category, 50, total number in that upper category. That goes in the bottom where it's in U. And then on the top is the number of people that got it correct out of that group, which is 30. We now look at the bottom, or the second part of the equation, that minus. So incorrect in the lower group is the number correct in the lower group. In this case, 15 got it correct out of the lower group. And how many people were in that lower group? 100. So 30 divided by 50 minus 15 divided by 100 becomes 0.6 minus 0.15. We get a D of 0.15. That's above a D of 0.35. This item is a fairly decent discriminator between top performers and bottom performers. Again, not perfect. Notice that only 30 out of 50 of the top performers got it right, and some of the people in the lower category got it right. So what we would find here is, let's think about how we'd get a perfect D. If we had 50 people in the upper category and all 50 got it right, 50 divided by 50 is 1. If 0 got it correct in the bottom, that would be 0 divided by 100. 0 divided by anything is 0. So 1 minus 1, our D equals 1.0. So if an item, everyone in the top category got it right, and everyone in the bottom category got it wrong, that would be perfect discrimination.